Hi guys, my name is Sanskriti and today I'll be explaining you about deadlock avoidance in operating system. So let's start with what is a deadlock. When two or more processes try to access the critical section at the same time or they fail to access simultaneously or stuck while accessing the critical section, then this condition is known as a deadlock. There are certain rules which you have to follow. First is every process needs a few resources to finish running. Second, the procedure makes the resource request. If the resource is available, the OS will grant it. Otherwise, the process will have to wait. When the process is finished, it is released. Then, waiting of a process. By this diagram, you can understand that P1 is a process, R1 and R2 are the requests. So R1 is in P1, means P1 is holding R1 and it is waiting for R2. This diagram tells us about hold and wait condition. Now, deadlock characteristics. There are four major characteristics of deadlock. First one is mutual exclusion. Second is circular wait. Third is hold and wait. Fourth is no preemption. Now, our main topic, deadlock avoidance. A deadlock avoidance policy grants a resource request only if it is established that granting the request cannot lead to a deadlock either immediately or in future. The kernel lacks detailed knowledge about future behavior of the process, so it cannot accurately predict deadlocks. To facilitate deadlock avoidance, under these conditions, it uses the following conservative approaches. Each process declares the maximum number of resource unit of each class that it may require. The kernel permits the process to request the resource unit in stage, that is, a few resource unit at a time, subject to maximum number of declared by it, and deadlocks. A request is granted only if there is no possibility of deadlocks. Otherwise, it remains pending until it can be granted. The approach is conservative because a process may complete its operation without require the maximum number of units declared by it. So this is what deadlock. Now we'll go for resource allocation graph and Banker's algorithm. By these two conditions, we can do deadlock avoidance. First one, resource allocation graph. The resource allocation graph, means RAG, is used to visualize the system current state as a graph. The graph includes all processes, the resources that are assigned to them, as well as the resources that each process requests. Sometimes, if there is fewer processes, we can quickly spot a deadlock in the system by looking at the graph rather than the tables we use in Banker's algorithm. Deadlock avoidance can also be done with the help of Banker's algorithm. So what is Banker algorithm? Banker's algorithm is a resource allocation and deadlock avoidance algorithm which tests all the requests made by the process for resources. It checks for the safe state and after granting the request system remains in the safe state. It allows the request, and if there is no safe state, it doesn't allow the request made by the process. Input to Banker algorithm. First one is maximum need of resource by each process. The currently allocated resource by each process. Third is maximum free available resource in the system. The request will only be granted under below conditions. So first one is if the request made by the process is less than or equal to the max needed for the process. Second is if the request made by the process is less than or equal to the freely available resource in the system. So here is an example. Total resource in system. So the total resource is A, B, C, D, which is allocated some number. Then available system resource, A, B, C, D is having some number stored in it. Then P1, P2, P3 are the three processes currently allocated resources, A, B, C, D, are having some numbers. Now maximum resource we have for the process means maximum resources are these many. Now how we will calculate the need? Need is whatever we are having as maximum resource request minus the currently allocated resource, or need equals to maximum resource minus CAR, same. So here we can see maximum resource below A, P1 is 3 and the currently allocated resource is 1. So 3 minus 1 is 2. We can just subtract maximum resource and available resource, will get the need. So our next is the conclusion of deadlock avoidance. Operating system employ deadlock avoidance to prevent deadlock by using the banker's algorithm or the resource allocation graph. Any of these you can use for the deadlock avoidance. Now deadlock avoidance work by informing the operating system of the resources needed by the process to finish execution, and the operating system then determines whether or not the requirement can be met. The system is said to be in safe state if all the resources required by the process are satisfied with